Think about the solar system for a moment, those familiar planets, moons, and the blazing sun at its center. It feels almost predictable, like a cosmic neighborhood we've mapped out completely. But what if I told you that beyond the textbook diagrams and glossy space photos, our solar system holds secrets so bizarre, so utterly unexplainable, that even the brightest scientists are left scratching their heads? Picture this: a moon spewing geysers of water into space, a planet with winds faster than the speed of sound, or a mysterious hexagonal storm raging at a pole, not of Earth but of another world entirely. These aren't scenes from science fiction. They're real, they're happening right now, and they're just the beginning of the strangeness lurking in our cosmic backyard. From the moment humans first gazed upward, we've been captivated by the mysteries of space. But as our telescopes grew sharper and our probes ventured farther, we didn't just find answers, we uncovered questions we never even thought to ask. Take Jupiter's moon Europa, for example. Beneath its icy crust lies an ocean with more water than all of Earth's seas combined, and scientists believe it could harbor life. Or consider Venus, Earth's so-called twin, where temperatures soar high enough to melt lead and the clouds rain sulfuric acid. These aren't just oddities, they're cosmic puzzles that challenge everything we think we know about how planets and life work. And that's just the tip of the celestial iceberg. Over the next few minutes, we're diving deep into 25 of the most mind-bending discoveries ever made in our solar system. Some will make you question reality, others might send a chill down your spine, but one thing's for certain: by the time we're done, you'll never look at the night sky the same way again. So buckle up, because the universe is stranger, wilder, and more mysterious than we ever imagined, and it's time to uncover its secrets together. Saturn, the ringed jewel of our solar system, holds a secret so bizarre it defies logic. At its north pole, a storm rages, not the swirling, chaotic mess you might expect, but a near-perfect hexagon stretching wider than Earth itself. Imagine a colossal, six-sided hurricane, with each side measuring over 8,000 miles long, spinning like a cosmic gear for decades without breaking its shape. This isn't some artist's rendering or a trick of the light. NASA Cassini spacecraft captured it in stunning detail, revealing a structure so precise it looks almost artificial. How does nature sculpt something so geometric in a realm where turbulence should rule? Scientists are still piecing together the puzzle, but one leading theory points to Saturn's unique atmosphere. Deep beneath its clouds, jet streams, rivers of gas moving at different speeds, might collide and create standing waves like vibrations in a plucked guitar string. These waves could force the storm into its hexagonal shape, with the planet's rapid rotation locking it in place. Another idea suggests that the hexagon acts like a giant vortex, a self-reinforcing pattern where the storm's own rotation keeps its edges razor-sharp. But here's the real kicker. While similar shapes have been recreated in lab experiments with spinning fluids, nothing on Earth comes close to the scale or stability of Saturn's masterpiece. What's even stranger, this hexagon isn't a fleeting phenomenon. It's been there since at least the 1980s, when Voyager first spotted it, and it's still going strong today. Storms on Earth fade in days or weeks, yet Saturn's hexagon has outlasted generations of scientists studying it. Some researchers think its longevity might be tied to the planet's lack of solid boundaries, no mountains or continents to disrupt the flow, allowing the pattern to persist in the pure, churning gas. Others speculate that hidden layers of atmosphere, deeper than we can see, act as an engine feeding the storm. The hexagon isn't just a curiosity, it's a window into the physics of alien worlds. If we can crack its code, we might unlock secrets about how gas giants evolve, how their atmospheres behave under extreme conditions, and even how similar patterns could arise on exoplanets light years away. For now, though, Saturn keeps its secrets, spinning that impossible hexagon like a cosmic riddle waiting to be solved. Jupiter's moon Io looks like something straight out of a fever dream, a world where the ground itself is alive, heaving and spewing fire into the blackness of space. If you could stand on its surface, you'd witness a landscape straight out of mythology. Rivers of molten rock, plumes of sulfur shooting hundreds of miles high, and mountains taller than Everest, all under the eerie glow of Jupiter's colossal shadow. This isn't just another rocky moon. Io is the most volcanically active place we've ever found, with eruptions so powerful they dwarf anything Earth has to offer. What makes Io such a cosmic inferno? The answer lies in a brutal gravitational tug of war. Jupiter's immense pull, combined with the rhythmic yanking of neighboring moons Europa and Ganymede, stretches and squeezes Io like a stress ball. This constant flexing generates tidal heating friction deep inside the moon that melts its core and keeps its crust in a state of perpetual eruption. The result, a surface covered in hundreds of active volcanoes, some blasting lava dozens of miles into the sky. And then there's the color. Io isn't just violent, it's garish. Sulfur compounds paint its surface in psychedelic yellows, oranges, and reds, giving it the appearance of a half-baked cosmic pizza. Some areas shine with fresh lava flows, while others are dusted in frosty sulfur dioxide snow, a bizarre contrast that makes Io one of the most visually surreal places in the solar system. But here's the real kicker. Io isn't just a spectacle. It's a laboratory. By studying its extreme geology, scientists are unraveling how tidal forces shape worlds, both in our solar system and beyond. Some speculate that moons like Io could exist around gas giants in distant star systems, their volcanic furnaces churning out clues about the potential for life in the most unexpected places. For now, though, Io remains a stark reminder that even in the cold void of space, fire and fury are always just beneath the surface. Saturn's moon Titan feels like a distorted mirror of Earth, a world where familiar landscapes twist into something alien and dreamlike. Here, rivers carve valleys into icy bedrock, rain drizzles from thick clouds, and vast lakes glisten under a hazy orange sky. But this isn't water. Titan's liquid is methane, a frigid hydrocarbon that flows at temperatures colder than -200 degrees Fahrenheit. It's the only place in the solar system, other than Earth, with stable liquid on its surface. But this isn't just a cosmic oddity. It's a laboratory for the bizarre, a place where chemistry takes turns we can barely imagine. Picture standing on Titan's shore, where waves of liquid methane lap against pebbles of water ice, hard as rock in the deep cold. The air is thick with nitrogen and laced with organic compounds, giving the sky its eerie, smog-like glow. Sunlight filters through the haze, weak and diluted, yet strong enough to drive weather cycles eerily similar to Earth's. Methane evaporates, forms clouds, and rains back down, filling lakes that span hundreds of miles. Some are shallow puddles, others, like Kraken Mare, are deeper than the Great Lakes, and just like Earth's oceans, they may hide secrets beneath their surfaces. What makes Titan truly tantalizing is the possibility of life, not as we know it, but something far stranger. In Titan's methane seas, where water is frozen solid and chemistry runs on hydrocarbons, scientists speculate about microbes that could use liquid methane the way Earth's life uses water. These hypothetical organisms would breathe hydrogen instead of oxygen and metabolize acetylene, thriving in conditions that would kill any earthly creature. NASA Cassini mission even spotted signs of hydrogen disappearing near Titan's surface, a hint that something might be consuming it. Then there's the chemistry. Titan's atmosphere is a factory for complex organic molecules, churning out compounds like ethane, propane, and even vinyl cyanide, a chemical some believe could form cell-like membranes in methane. If life exists here, it wouldn't just be an outlier, it'd be proof that biology can emerge in environments we once thought impossible. Future missions like NASA's Dragonfly drone aim to soar through Titan skies in the 2030s, sampling its dunes and searching for clues. Until then, Titan remains a haunting question. Is it a frozen wasteland with fleeting resemblances to home, or the first glimpse of life's true cosmic diversity? One thing's certain: this moon doesn't just challenge our definitions of habitability, it rewrites them. Beneath Europa's cracked, icy shell lies one of the most tantalizing secrets in our solar system, a hidden ocean so vast it could hold twice the water of all Earth's seas combined. This isn't just a frozen wasteland, it's a world where geysers blast water into space through fractures in the ice, where tidal forces from Jupiter's gravity keep the subsurface liquid, and where the ingredients for life might be stirring in the darkness. Picture this: an ocean not of miles, but of dozens of miles deep, sealed under an ice crust as thick as some mountains. Yet despite the unimaginable pressure and perpetual night, Europa's waters could be far from lifeless. Hydrothermal vents like those on Earth's ocean floors might dot its depths, spewing minerals and warmth into the water. On our planet, such vents teem with extremophiles, organisms thriving in conditions once thought uninhabitable. If Europa has similar energy sources, who's to say what could be swimming in those alien seas? The evidence keeps piling up. NASA Galileo spacecraft first spotted Europa's fractured, shifting surface in the 1990s, hinting at a liquid layer beneath. Later observations caught plumes of water vapor erupting into space, as if the moon itself were offering samples to anyone daring enough to collect them. Then there's the reddish-brown gunk staining Europa's icy grooves, possibly salts or organic compounds brought up from the ocean below. That's why scientists are itching to get a closer look. Missions like Europa Clipper, launching in the 2020s, will skim just miles above the surface, mapping the ice shell and sniffing those plumes for chemical fingerprints of life. Even wilder plans involve melting probes or robotic submarines to breach the ice and explore the abyss directly. But the real question isn't just whether Europa has water, it's whether it has a story to tell. If life exists there, isolated beneath the ice for billions of years, it would prove that biology isn't a fluke of Earth alone. It would mean the universe is far more creative, far more generous with its chances than we ever dreamed. Europa doesn't just challenge our search for life, it redefines where we should look. Staring at Saturn's moon, Iapetus feels like witnessing a cosmic glitch, a celestial body that defies every expectation of balance. One hemisphere gleams brilliantly, reflecting sunlight like freshly fallen snow, while the other side absorbs light like charcoal, so dark it nearly vanishes against the blackness of space. This isn't subtle shading, it's the starkest contrast found anywhere in our solar system, as if someone took a paintbrush and split the moon down the middle. But the strangeness doesn't stop there. Iapetus also boasts a colossal ridge running perfectly along its equator, a feature so precise it looks like the seam of a walnut shell, stretching over 800 miles long and towering 12 miles high in places. What could possibly create such an extreme dichotomy? The dark side, known as Cassini Reggio, is coated in a mysterious material that's had scientists debating for centuries. Some believe it's residue left behind as Iapetus plows through dusty debris from Phoebe, another of Saturn's moons. As the material settles on the leading face of Iapetus, sunlight warms that side just enough to trigger a runaway process. Dark areas absorb more heat, vaporizing nearby ice and leaving even darker deposits behind. Others argue the darkness might bubble up from within, with ancient organic compounds erupting through cracks in the crust like a slow-motion ink spill across half the moon. Then there's the ridge, an enigma wrapped in a riddle. No other moon in our solar system has a feature quite like it. Some theories suggest it formed during a rapid spin early in Iapetus's history, when the moon's rotation could have flung material outward until it froze into this bizarre belt. Others propose a more violent origin, the shattered remains of a smaller moon that once orbited Iapetus, torn apart by tidal forces and raining down along the equator. The most daring idea, that the ridge is a relic from when Iapetus was younger and slightly squishier, its surface buckling as the moon cooled and shrank, squeezing material upward in a single continuous line. What makes Iapetus truly remarkable isn't just its appearance, it's how these features intertwine. The ridge's shadow might actually reinforce the two-toned effect, trapping dark material on one side while leaving the other exposed to space's bleaching effects. Every time we look closer, this moon seems designed to keep us guessing. Even the way it orbits Saturn is peculiar, tilted at an angle far steeper than most moons, as if it were captured rather than born in place. Iapetus doesn't just challenge our understanding of moons, it forces us to rethink how celestial bodies evolve. In a universe where gradual processes usually smooth out extremes, this moon stands as a defiant exception, a reminder that nature's rulebook has pages we haven't even glimpsed yet. For now, it remains one of Saturn's most cryptic masterpieces, a yin-yang puzzle hanging in the void. Imagine a planet so far from its star that a single orbit takes 15,000 years, a lonely giant drifting in the cosmic deep like a ship lost at sea. HD 106906b isn't just another exoplanet. It's a celestial rebel, defying every rule we thought we knew about how planetary systems form. 11 times more massive than Jupiter, it orbits its host star at a distance so vast it makes Pluto's stroll around the Sun look like a tight hug. At 650 times Earth's distance from its star, this world languishes in near-total darkness, where the Sun is little more than a particularly bright star in an endless night sky. How does a planet end up in such a freakish orbit? The leading theory is cosmic chaos in action. Scientists suspect HD 106906b was born much closer to its star, but gravitational tugs from a companion star, or a close brush with another planet, flung it outward like a stone from a slingshot. Normally, such a planet would escape entirely, becoming a rogue world adrift between stars. But here's the twist: perhaps the gentle pull of that distant companion star tugged it back just enough to keep it tethered, leaving it stranded in this absurdly wide orbit. What's even stranger is the planet's sprawling debris disk. Think of Saturn's rings, but on steroids, a vast belt of dust and rubble stretching hundreds of times farther than Earth's orbit around our Sun. This disk shouldn't exist so far out, yet there it is, hinting at a violent past where planets might have collided or been ejected. Some researchers wonder if HD 106906b is the sole survivor of a planetary massacre, the last giant standing in a system that once looked very different. But the real shocker: this planet shouldn't have lasted. At its distance, the star's gravity is whisper-weak, leaving the planet vulnerable to passing stars or galactic tides that could yank it away forever. The fact that it's still there suggests we're missing a piece of the puzzle, maybe hidden planets lurking unseen, or forces we haven't yet imagined. HD 106906b isn't just a curiosity, it's a challenge to our textbooks. If planets can be hurled into such extreme orbits and survive, what else is possible? Could there be other frozen giants exiled to the fringes of their systems, waiting to be found? Or does this planet represent a freak accident, a cosmic fluke we happen to catch? One thing's certain: the universe loves to remind us that for every rule we write, there's always an exception, and it's usually stranger than fiction. In a galaxy not so far away, there's a planet that would make even the most extravagant jewelers blush, a world where the very ground beneath your feet might glitter with diamonds. Meet 55 Cancri, a super-Earth twice our planet's size, orbiting so close to its star that a single year lasts just 18 hours. But it's not the speed that's shocking, it's what scientists think lies beneath its scorching surface. This isn't just a rocky world, it's a carbon-rich marvel where a third of its mass could be pure diamond, compressed into crystalline structures we can barely imagine. Picture standing on 55 Cancri's surface if you could survive the inferno. Dayside temperatures soar above 4,000 degrees Fahrenheit, hot enough to melt steel, while the night side, locked in eternal twilight, still bakes at a brutal 2,000 degrees. The atmosphere, a suffocating mix of hydrogen and helium laced with vaporized rock, but dig beneath this hellish exterior and things get even wilder. The planet's carbon-heavy composition means its mantle might not be molten rock like Earth's, but a seething ocean of liquid diamond with solid diamond icebergs floating atop it. Some models suggest its core could be a single planet-sized gem, a diamond larger than Earth's moon. How does such a planet even form? This is where 55 Cancri E turns textbook theories upside down. Planets typically condense from the same swirling cloud of gas and dust as their star, rich in oxygen and silicon ingredients for rocks and sand, not jewels. But 55 Cancri E star has double the carbon of our Sun, tipping the scales toward carbon-based chemistry. Under extreme heat and pressure, that carbon crystallizes into diamond, creating a world that's essentially a cosmic jewelry store. Yet the real mystery isn't just its sparkle, it's why this planet exists at all. Conventional wisdom says gas giants like Jupiter should dominate carbon-rich systems, hoarding all that precious material. But 55 Cancri E defies the odds, a diamond-studded puzzle that's making astronomers rethink how planets assemble themselves. Some speculate it might be the remnant core of a gas giant whose atmosphere was vaporized by its star, leaving behind this glittering relic. Others wonder if it formed farther out where carbon could condense freely before migrating inward. The implications stretch beyond our solar system. If diamonds can coat entire planets, what other exotic worlds might lurk out there? Graphite continents, silicon carbide deserts. 55 Cancri E doesn't just dazzle, it forces us to expand our vision of what's possible. For now, it remains a fiery enigma, a reminder that the universe's treasures aren't just in the stars but sometimes beneath them. Enceladus, Saturn's icy moon, isn't just another frozen rock. It's a cosmic fire hose, blasting plumes of water hundreds of miles into space like a celestial fountain. These aren't mere geysers, they're cryovolcanic eruptions powered by an underground ocean that could hold the keys to one of humanity's biggest questions. Are we alone in the universe? Picture a world where towering jets of icy particles shoot through fractures in the surface called tiger stripes, creating a shimmering halo around the moon itself. But the real magic isn't in the spectacle, it's in what those plumes contain. When NASA Cassini spacecraft flew through these jets, it didn't just find water vapor. Hidden in the mix were organic molecules, carbon-rich compounds like methane, propane, and even formaldehyde, the building blocks of life as we know it. And that's not all. The plumes also spat out tiny silica grains, which on Earth are typical byproducts of hydrothermal vents, those very same vents that support thriving ecosystems in our planet's deepest, darkest oceans. That's the jaw-dropper. Enceladus might have hydrothermal activity simmering beneath its icy shell, a recipe that on Earth leads straight to life. Now imagine what's lurking in that hidden ocean. Heated by Saturn's gravitational tug, kept liquid by antifreeze like salts, and churning with organic material, it's a cosmic petri dish just waiting to be studied. Some scientists speculate that if microbes exist there, they could resemble Earth's extremophiles, clinging to hydrothermal vents in the abyss. Others go further, suggesting Enceladus's ocean might host entirely alien biochemistries, life forms that don't need sunlight or oxygen, thriving in perpetual darkness. The implications are staggering. Enceladus isn't just a moon, it's a beacon, telling us that the ingredients for life aren't rare or special. They're scattered throughout the solar system, hidden in the unlikeliest places. And here's the kicker, those plumes are practically handing us samples. Future missions could fly through them, scooping up material without even landing, searching for amino acids or just maybe the unmistakable fingerprints of living organisms. So why haven't we found proof yet? The challenge is in the details. Organic molecules can form without life, and silica grains could come from other geologic processes. But with every new discovery, the puzzle pieces fit tighter. Enceladus isn't just a curiosity, it's a test case for how life might arise in icy moons across the galaxy. If something stirs in those dark, salty depths, it wouldn't just rewrite textbooks, it would redefine humanity's place in the cosmos. Until then, those crimson-stained jets keep whispering their tantalizing secret. Life, it seems, might be closer than we ever dared to hope. Miranda, Uranus's misfit moon, looks like it was pieced together by a careless cosmic sculptor. A world where 100-mile-high cliffs loom over cratered plains and jagged canyons split the surface like cracks in shattered glass. This isn't the smooth, predictable terrain of most moons. It's a chaotic jumble of geologic nightmares, as if Miranda couldn't decide what shape it wanted to be. Some regions look polished and ancient, while others are crumpled and fresh, like a planet-sized ball of clay smashed flat and hastily reassembled. So what caused this pandemonium? The leading theory is a history of violence, a series of catastrophic impacts that shattered Miranda's icy crust over and over again. Imagine moon-sized wrecking balls slamming into its surface, fracturing the ground into colossal shards that later refroze at odd angles, leaving behind those dizzying cliffs. One feature Verona Rupes is the tallest known cliff in the solar system, a sheer drop so extreme that if you slipped off the edge, it would take you nearly 12 minutes to hit the bottom. But impacts alone don't explain everything. Some scientists believe tidal forces from Uranus played a role, stretching and compressing Miranda's interior until it literally ripped itself apart, spewing slushy ice onto the surface in titanic eruptions. Then there's the chevron, a bizarre, V-shaped region of grooves and ridges that looks like it was stamped onto the moon by some celestial cookie cutter. Nothing like it exists anywhere else in the solar system. Was it carved by a glacier of slowly flowing ice, the scar of an ancient tectonic rupture? Or is it the ghost of a long-lost moonlet that collided with Miranda and left its imprint behind? What makes Miranda truly fascinating isn't just its appearance, it's what it tells us about resilience. This moon endured apocalyptic forces, yet instead of being obliterated, it became a patchwork of survival. Some areas are clearly older, battered by eons of impacts, while others gleam with geologic youth, repaved by cryovolcanic ooze. It's a testament to how planetary bodies can heal, or at least try to after unimaginable trauma. Miranda doesn't just challenge our ideas of how moons form. It forces us to reconsider what happens when worlds get second chances. If a place this shattered can still cling to its identity, what other battered survivors might be hiding in the darkness beyond? Uranus doesn't just roll on its side, it plays by its own rules when it comes to magnetism too. While Earth's magnetic field lines up neatly with its rotation axis, Uranus's is downright rebellious, tilted a staggering 60 degrees off kilter. Imagine holding a compass on this icy giant. Instead of pointing toward the North Pole like ours does, the needle would swing wildly off to the side, as though the planet itself can't decide which way is up. This isn't just a quirk, it's a full-blown cosmic conundrum that forces scientists to rethink how magnetic fields are born in the first place. Most planets generate their magnetic fields through what's called a dynamo effect, a churning core of conductive material like Earth's molten iron that acts like a giant electromagnet as the planet spins. But Uranus's lopsided field suggests something far stranger is at work. One leading theory, the dynamo might not be in the core at all, but higher up, in a slushy ocean of ionized water and ammonia sandwiched between the icy mantle and rocky interior. If this layer is uneven, thicker in some places, thinner in others, it could create a magnetic field that's as off balance as the planet's infamous tilt. Then there's the timing. Unlike Earth's steady magnetic shield, Uranus's field might flicker on and off as it rotates, like a cosmic light switch stuck halfway. Data from Voyager 2 revealed the field's strength varies wildly depending on where you measure it, almost as if the planet's magnetism is stuttering. Some researchers think this could mean the dynamo is shallow and disorganized, with pockets of conductive material swirling in chaotic currents rather than a unified flow. Others propose that Uranus's extreme seasons, each pole getting 42 years of continuous sunlight followed by 42 years of darkness, could be warping the magnetic field over time, twisting it into this bizarre configuration. The implications stretch beyond Uranus. If magnetic fields can form in these unexpected ways, what does that mean for the thousands of exoplanets we've discovered? Could some have magnetic shields that are even weirder, perhaps patchy or lopsided like Uranus's? And how does this affect the potential for life? Earth's magnetic field protects us from deadly solar radiation. Without it, our atmosphere would be stripped away. A wonky field like Uranus's might offer uneven protection, leaving some regions exposed while others are sheltered. For now, Uranus keeps its secrets locked beneath layers of icy haze. But every oddity we uncover, the tilted field, the flickering dynamo, the shallow magnetic engine, chips away at our assumptions, reminding us that nature's creativity knows no bounds. This isn't just a puzzle for planetary scientists. It's a masterclass in how much we still have to learn about the hidden workings of worlds, both in our solar system and beyond. Neptune's great dark spot isn't just a storm, it's a phantom, a cosmic illusion that appears and vanishes like a shadow in the night. When Voyager 2 raced past Neptune in 1989, it spotted a colossal tempest in the planet's southern hemisphere, a swirling maelstrom as wide as Earth itself. Winds howled at over 1,000 miles per hour, the fastest in the solar system, twisting the storm into a dark, gaping hole in Neptune's cerulean atmosphere. But by the time the Hubble Space Telescope turned its eye toward Neptune in the 1990s, the spot was gone, vanished without a trace. Then, years later, another dark vortex appeared, this time in the northern hemisphere. It wasn't the same storm, it was something new, something equally mysterious. What makes Neptune's dark spot so different from Jupiter's great red spot? For starters, Jupiter's iconic storm has raged for at least 4 centuries, maybe longer, while Neptune's spots come and go like celestial soap bubbles. The Great Red Spot is a high-pressure system, a towering anticyclone that spins like a relentless cog in Jupiter's atmosphere. But Neptune's dark vortices are something else entirely. They're likely holes in the upper cloud deck where gases plunge deep into the planet's interior, revealing the darker, warmer layers beneath. Imagine a cosmic drain pulling material downward with such force that it leaves a void in its wake. And here's the twist. These spots might not just be atmospheric quirks, they could be windows into Neptune's hidden depths. Some scientists suspect they form when disturbances in the planet's lower atmosphere ripple upward, breaking through the upper cloud layers like geysers in reverse. Others think they're fueled by temperature contrasts between Neptune's frigid outer atmosphere and its surprisingly warm interior, a leftover heat from the planet's violent formation. The real enigma, though, is why these storms don't last. Jupiter's Great Red Spot survives because it's fed by smaller eddies and jets that constantly reinforce it. Neptune's dark spots, by contrast, seem isolated, starved of the energy needed to sustain them. Without a steady supply of swirling turbulence, they weaken, stretch, and finally dissipate, leaving no clue as to when or where the next one might emerge. What's even more fascinating is how these spots reflect Neptune's wild personality. Unlike Earth, where storms are driven by sunlight heating the surface, Neptune's weather runs on internal fire. The planet radiates more than twice the heat it receives from the distant sun, meaning its gales and vortices are powered from within. This could explain why Neptune's winds outpace even Jupiter's and why its storms behave so unpredictably. For now, Neptune's dark spots remain fleeting ghosts, here one decade and gone the next. Each new observation raises more questions than answers, but that's the allure of this blue giant. It doesn't just defy expectations, it rewrites them entirely, proving that even in the outer solar system, where the sun is little more than a bright star, the forces of nature still have surprises up their sleeves. Pluto's moons Nix and Hydra don't just orbit their dwarf planet, they dance on the edge of chaos, tumbling through space like cosmic drunkards stumbling home after midnight. These aren't the predictable, steady companions we're used to seeing in the solar system. Instead, they spin erratically, flipping end over end with no discernible pattern. Their rotations so unpredictable that even astronomers can't pin down their exact movements from one day to the next. And the culprit behind this celestial pandemonium, a gravitational tug of war so intense it warps the very fabric of their orbits. At the heart of this chaos is Charon, Pluto's largest moon. Unlike Earth and our moon, where the moon orbits a much larger central body, Pluto and Charon are practically twins in size, locked in a mutual orbit around a shared point in space. This creates a gravitational maelstrom that yanks on smaller moons like Nix and Hydra, destabilizing their spins with relentless force. Imagine trying to walk straight while two massive friends keep shoving you in opposite directions. That's life for these moons. Their irregular, potato-like shapes only make things worse, with uneven mass distribution turning their rotations into a dizzying spectacle. But here's where it gets even stranger. Hydra, the outermost of the two, spins like a top on steroids, completing a full rotation every 10 hours while also orbiting Pluto every 38 days. Nix, meanwhile, flips so wildly that its north pole might suddenly become its south pole in a matter of orbits. Scientists describe their movements as chaotic rotation, a term that sounds more at home in a physics nightmare than in a stable planetary system. And because of this chaos, the sunlight hitting their surfaces scatters unpredictably, making their brightness flicker like cosmic strobe lights. The implications stretch far beyond Pluto. Systems like this challenge our understanding of how moons form and behave, proving that even in the frigid outskirts of the solar system, gravity can turn harmony into bedlam. If something as seemingly simple as a moon's spin can defy prediction, what other hidden complexities are lurking in the cosmos? Nix and Hydra don't just wobble, they force us to question the very nature of stability in the universe. Yet amid the turmoil, there's a peculiar beauty to their disorder. These moons are cosmic rebels, refusing to conform to the neat, clockwork motions we expect from celestial bodies. They remind us that the universe thrives on unpredictability, that even in the coldest, most distant reaches, chaos and wonder go hand in hand. And as we study their erratic pirouettes, one thing becomes clear. The solar system isn't just a collection of rocks and gas, it's a stage, and some of its performers refuse to follow the script. Deep in the asteroid belt between Mars and Jupiter floats a relic so strange it shouldn't exist, an exposed planetary core naked to the void. This isn't just another space rock. 16 Psyche is a metallic world, a jagged, cratered sphere made almost entirely of iron and nickel, gleaming like a cosmic forge left out to cool. If you could slice it open, you'd find a composition eerily similar to Earth's own core, as if someone cracked open a planet and spilled its secrets into the darkness. How does a metal world like this even form? The leading theory reads like a cosmic horror story. Psyche might be the shattered heart of a doomed protoplanet, one that began forming like any other in the early solar system, until catastrophic collisions stripped away its rocky mantle and crust, leaving only the dense metallic core behind. Imagine a planet-sized peach, its flesh ripped off by some celestial monster, leaving nothing but the pit spinning in the void. That's Psyche, a survivor of the solar system's most violent era, a time when planets weren't yet finished and collisions reshaped worlds. But here's the twist, we've never seen anything like it up close. Every other world we've studied, from Mercury to Pluto, has a rocky or icy exterior. Psyche is the only known metal-dominated body in our cosmic neighborhood, making it a Rosetta Stone for understanding how planets assemble themselves. That's why NASA is sending a mission to orbit it in 2026, armed with instruments to map its composition, magnetic field, and bizarre topography. Scientists suspect its surface could be studded with metal cliffs, solidified lava flows of molten iron, and impact craters that glitter with exposed nickel seams. Some even speculate about metal volcanoes, cryovolcanoes that once spewed liquid metal instead of magma. The mission stakes are staggering. If Psyche is indeed a primordial core, studying it could reveal secrets about Earth's own inaccessible center, where similar metals churn beneath thousands of miles of rock. It might also rewrite the story of how rocky planets like ours are born. Current models suggest cores form first, with mantles and crusts building up later. But Psyche's existence hints at a messier process where collisions and chaos play a bigger role than we thought. Then there's the wild card, Psyche's magnetic field. Earth's magnetic shield comes from its liquid outer core, but Psyche is solid now. If remnants of an ancient field linger, frozen into its metal, it could revolutionize our understanding of how planetary dynamos work or flicker out. And let's not forget the economic daydreams. With enough metal to dwarf Earth's entire mining industry, Psyche has sparked controversial debates about asteroid mining, though bringing even a fraction of its mass home remains science fiction for now. Psyche doesn't just tantalize scientists, it challenges our very definition of a world. Is it a corpse of a failed planet, a time capsule from the solar system's birth? Or something even stranger, a metallic oddball that defies all categories? Soon we'll have answers. Until then, it spins silently, a glint of metal in the dark, holding tales of cosmic violence we've only begun to decipher. Mercury might be the smallest planet, but its scars tell the most violent stories, especially the eerie spider terrain near its north pole. Picture this, a massive crater named Caloris Basin, surrounded by hundreds of jagged fractures radiating outward like cracks in a shattered windshield. These aren't random scars, though they form intricate web-like patterns stretching for hundreds of miles, as if some colossal arachnid etched its mark into the planet's crust. But the real shocker, these fractures aren't from impacts. They're whispers of a volcanic tantrum frozen in time, a hidden chapter in Mercury's fiery past. What could create such bizarre formations on a world often dismissed as a barren, airless rock? The answer lies beneath the surface. Mercury once seethed with volcanic fury, its molten core belching lava that pooled and cooled, straining the planet's brittle outer shell. As that magma retreated, the ground above collapsed inward, fracturing like drying mud, except these cracks didn't just crumble. They exploded outward in starry bursts, driven by pressures we'd struggle to replicate even in labs. Some scientists compare it to a souffle collapsing after baking, but on a planetary scale where the crust splintered into this haunting spiderweb, the oddest part. These spiders seem to cluster near Mercury's poles, far from the planet's volcanic hotspots. One theory suggests that volatile compounds, like sulfur or even water ice trapped in shadowed craters, might have vaporized when magma neared the surface, blasting the terrain apart like a buried bomb. Others propose that Mercury's extreme temperature swings from 800 degrees Fahrenheit during the day to -290 at night, weaken the crust over eons, making it shatter more easily under stress. But here's the twist, these spiders might still be active. NASA messenger probes spotted hollow, bright, shallow pits dotting the fractures that appear fresh, as if something is still eating away at the surface. Could residual heat or escaping gases be reshaping Mercury even today? It's a chilling thought for a world long assumed to be geologically dead. The spider terrain isn't just a curiosity, it's a window into Mercury's volatile soul. This tiny planet endured billions of years of solar bombardment, yet its scars reveal a history far more dynamic than we ever imagined. If such fury lurks beneath the calm facade of the solar system's smallest world, what other secrets are we missing on the giants? Mercury's spiders don't just creep across its surface, they crawl into our assumptions, forcing us to rethink what dead really means in the cosmos. Mars has a secret one that comes and goes like a ghost in the data. Scientists have been detecting whiffs of methane in its thin atmosphere for years, only for them to vanish without warning. This isn't just another oddity. Methane is a gas that, on Earth, is overwhelmingly tied to life. From cow burps to swamp bacteria, living organisms churn it out constantly. So when our rovers and orbiters catch traces of it on Mars, the question becomes electrifying. Is this a sign of something alive beneath the rust-colored soil, or just another geological trick? The mystery lies in the methane's fickle behavior. NASA Curiosity rover, trundling through Gale Crater, has recorded sporadic spikes, sometimes 10 times the background levels, that last only hours before dissipating. Europe's Trace Gas Orbiter, meanwhile, has often found the atmosphere eerily clean, as if the methane vanishes into thin air. This inconsistency drives researchers to distraction. If the gas were being steadily released by volcanic activity or underground chemical reactions, why wouldn't it build up over time? Yet if microbes are producing it, why don't we see more? Geologists point to possible explanations buried deep in Mars's crust. Serpentinization, a process where water reacts with certain rocks, can produce methane without any biology involved. Or perhaps ancient methane, trapped in ice cages called clathrates, occasionally bursts free when temperatures shift. But here's the twist: methane on Mars should linger for centuries before sunlight breaks it down. The fact that it disappears so quickly hints at an unknown destructive force, maybe electric winds scrambling molecules or unseen chemical reactions in the soil. Then there's the biological angle. On Earth, some microbes thrive miles underground, far from sunlight, metabolizing hydrogen and carbon dioxide into methane. Could similar extremophiles be eking out an existence in Mars's damp subsurface brines? The idea isn't far-fetched. Recent experiments show certain Earth bacteria can survive Martian conditions, hibernating in salt crystals until water returns. If life ever took hold on Mars, it might have retreated underground, flickering to life when conditions allow. The stakes couldn't be higher. If the methane is geological, it still rewrites our understanding of Mars as a dead world, proving its interior is more active than we thought. But if it's biological, it would mean life isn't just an earthly fluke. It's a shadow dancing at the edge of our detection, daring us to look closer. Future missions like the Mars Life Explorer aim to drill deeper, hunting for answers where the whispers of methane begin. Until then, the red planet keeps its secret, teasing us with clues that vanish as quickly as they appear. The Moon's surface hides a series of ghostly patterns, delicate, bright swirls that curl across the dusty plains like cosmic fingerprints. These aren't random stains, they're lunar swirls, some stretching hundreds of miles, their ethereal glow standing out starkly against the dark lunar regolith. But what makes them truly baffling isn't their beauty, it's the fact that they're tied to magnetic fields, something the Moon shouldn't have in such localized, powerful patches. Our Moon lacks a global magnetic shield like Earth, yet these swirling regions defy expectations, creating miniature force fields that dance across the surface like invisible fences. The leading theory, ancient cosmic violence. When massive asteroids slammed into the Moon billions of years ago, they might have vaporized chunks of the lunar crust, creating clouds of superheated plasma. As this charged gas expanded and cooled, it could have locked in traces of the Moon's then active magnetic field, freezing it into the rock like a snapshot of primordial chaos. Over time, lava flows might have covered these magnetized zones, leaving behind a patchwork of hidden magnetic bubbles. Now, when solar wind, a stream of charged particles from the sun, bombards the Moon, these magnetic shields deflect the radiation, preventing the surrounding soil from darkening like the rest of the surface. The result, those eerie, bright swirls where the dust stays strangely pristine while the rest of the moon weathers into a dull gray. But there's a wilder idea. Some scientists propose these swirls could be relics of comet strikes. As a comet's icy nucleus smashed into the moon, the sudden explosion of gas and dust might have generated a temporary magnetic field, imprinting it onto the lunar crust before vanishing. Others wonder if underground lava tubes, long since cooled, retain magnetic minerals that funnel solar wind in unpredictable ways, creating these artistic splatters. The mystery deepens when you consider Rheinair Gamma, the most famous swirl, a sprawling, tadpole-shaped formation that seems to defy erosion entirely. Lunar probes have detected elevated magnetism here, but the patterns don't always match the swirls perfectly, suggesting something even stranger is at play. Could electrostatic forces be lifting dust particles, sorting them by size or composition? Or is there some unseen interaction between the moon's residual magnetism and the solar wind we haven't yet decoded? One thing's certain, these swirls aren't just scientific curiosities. They're potential treasure maps for future explorers. Magnetic anomalies could shield astronauts from deadly solar radiation, making them ideal spots for lunar bases. And if we can unravel how these fields formed, we might unlock secrets about the moon's volcanic past, its lost magnetic dynamo, and even similar phenomena on airless worlds like Mercury. For now, the moon keeps its swirling secrets, a celestial artist painting in magnetic whispers. Each new orbit, each fresh scan, brings us closer to understanding, but the answers, like the swirls themselves, remain just out of reach, shimmering in the quiet darkness. Ceres, the largest object in the asteroid belt, hides a geological oddity that defies everything we know about volcanoes. Towering over this tiny dwarf planet is Ahuna Mons, a cryovolcano unlike anything else in the solar system. Picture a mountain 4 miles high, its slopes not carved from lava and ash, but from frozen brine and mud that ooze to the surface like icy toothpaste. This isn't the fiery, explosive volcanism of Earth or even the sulfur-spewing vents of Io. Ahuna Mons is a silent giant, built by the slow, stubborn force of water and salt erupting into the bitter cold of space. What makes this icy behemoth even stranger is its isolation. Most volcanoes, whether fiery or frozen, cluster in groups, hinting at active hotspots beneath the crust. But Ahuna Mons stands alone, a solitary sentinel on Ceres's otherwise bland surface. Scientists believe it formed when pockets of salty water, laced with ammonia or methane, were squeezed upward by internal pressure. As this briny sludge reached the surface, it froze almost instantly in the vacuum of space, piling up layer by layer over millions of years. The result? A mountain that's more glacier than volcano, its smooth sides scarred only by the occasional landslide. Then there's the mystery of its youth. Ahuna Mons lacks the craters that pockmark the rest of Ceres, suggesting it's a relative newcomer in geologic terms, maybe just 200 million years old. That's a blink of an eye for a dwarf planet that's been around since the solar system's infancy. How could cryovolcanism still be happening on such a small, cold world? Ceres has no massive neighbor like Jupiter to tug at its insides, no radioactive decay to keep its core warm. Yet somehow, beneath that icy crust, there's enough energy, or at least there was recently, to push an entire mountain into existence. The answer might lie in Ceres's hidden ocean. Data from NASA's Dawn spacecraft revealed bright spots in Iapetus crater, deposits of sodium carbonate that hint at briny liquids seeping up from below. If pockets of saltwater still slosh beneath the surface, kept liquid by antifreeze-like compounds, they could periodically burst through weak points in the crust, creating cryovolcanoes like Ahuna Mons. Some researchers even speculate that Ceres might have a layered interior, with a muddy, slushy mantle separating a rocky core from the icy shell, a setup that could allow slow, persistent geologic activity. But here's the real twist. Ahuna Mons might not be a one-time fluke. Other, smaller domes dot Ceres' surface, some partially collapsed, as if they were once volcanoes that have since sagged back into the ground. This suggests that Ceres has been sputtering icy eruptions for eons, reshaping itself in a cycle of freeze and fracture. If that's true, then dwarf planets long dismissed as boring, inert rocks might be far more dynamic than we ever imagined. Ahuna Mons doesn't just challenge our ideas about volcanism, it forces us to reconsider where geologic activity can happen. If a tiny world like Ceres, stranded between Mars and Jupiter, can muster the energy to build mountains of ice, what other frozen wonders might be lurking in the outer solar system? The answer could rewrite the story of how small worlds evolve, and whether some of them, against all odds, might still hold the warmth for life. Deep in the frigid darkness of the Kuiper belt, a cosmic snowman floats silently, a relic so ancient it carries whispers from the solar system's birth. Arakoth, formerly nicknamed Ultima Thule, isn't just another icy rock. This bizarre, bi-lobed world looks like two pancakes glued together at the seams, forming a shape so peculiar it defies the smooth, rounded objects we're used to seeing. When NASA New Horizons spacecraft raced past it in 2019, it captured the most distant close-up images ever taken, revealing a world frozen in time, unchanged for over 4 billion years. What makes Arakoth's form so astonishing isn't just its whimsical appearance, it's the story it tells about how planets were born. Unlike asteroids forged by violent collisions, Arakoth's two lobes show no impact scars, no signs of crushing force. Instead, they're gently pressed together like two dancers meeting in slow motion. Scientists believe this is how all planetesimals, the building blocks of planets, first formed. Tiny clumps of dust and ice sticking together in the protoplanetary disk, merging so delicately that their original shapes remained intact. It's a cosmic snapshot of infancy, a preserved moment from when the solar system was just a swirling nursery of debris. The details get even stranger. The larger lobe, named Ultima, is flatter than a pancake, while the smaller one, Thule, is more rounded, as if the universe couldn't decide on a single design. Their surfaces are eerily smooth, dotted with subtle pits but devoid of craters, suggesting Arakoth has drifted undisturbed since the dawn of time. Even its color is a puzzle, a uniform reddish hue, likely from organic molecules called tholins baked by eons of cosmic radiation. These compounds are the same ones that give Pluto its rusty tint, but here they coat a world that's never felt the warmth of the sun. The real revelation, though, is how Arakoth challenges old assumptions. For decades, astronomers thought planet formation was a violent, chaotic process, a demolition derby of rocks smashing together at high speed. But Arakoth's gentle union suggests the early Kuiper belt was more like a slow-motion ballet, where objects orbited peacefully until gravity nudged them into a tender embrace. This changes everything. If small worlds formed this way, then the giants like Earth and Mars might have begun as stacks of smaller bodies, layered together with care rather than fury. Yet mysteries linger. Why didn't Arakoth's two halves merge into a single sphere over time? Why does one lobe look squashed while the other stays round? Some theorists point to its slow spin, a leisurely 15-hour rotation, as a clue, suggesting the lobes never had enough energy to fully coalesce. Others wonder if we're seeing a stalled process, a half-finished world that never grew beyond this peculiar shape. Arakoth isn't just a time capsule, it's a Rosetta Stone for decoding planetary origins. Every ridge, every color gradient, every chemical signature is a syllable in a story written 4.5 billion years ago. As New Horizons voyages farther into the void, its cameras now dark, the data it sent back continues to reshape our understanding of beginnings. And Arakoth, that silent snowman in the dark, remains the ultimate witness, a testament to the quiet, delicate dance that built the worlds we know today. Venus wasn't always the hellscape we see today. It may have once been draped in oceans, much like Earth. But where did all that water go? The answer lies in a force so unexpected it sounds like science fiction. An electric wind, a supersonic gale of charged particles roaring through Venus's atmosphere with enough power to strip away an ocean's worth of hydrogen over billions of years. This isn't just a gentle breeze, it's a planetary-scale vacuum, pulling atoms into space with an efficiency that shocked scientists when they first measured its strength. Here's how it works. Venus, lacking a global magnetic field like Earth's, is exposed to the full fury of the solar wind, a stream of charged particles blasting from the sun. But something unexpected happens when these particles collide with Venus's thick carbon dioxide atmosphere. The sun's ultraviolet radiation ionizes the gas, creating a layer of positively charged ions near the planet's upper atmosphere. These ions, caught in the grip of Venus's gravity, would normally stay put except for the planet's intense electric field, generated by the imbalance between escaping electrons and heavier ions. This field acts like a cosmic slingshot, accelerating those ions to escape velocity. The result, a relentless, invisible gale ripping hydrogen, the key ingredient in water, right off the planet and flinging it into space. The numbers are staggering. ESA's Venus Express mission found this electric wind is 5 times stronger than Earth's, and possibly the strongest of any planet in our solar system. Over time, it could have siphoned away enough hydrogen to drain Venus's ancient oceans, leaving behind the parched, acidic wasteland we see today. But here's the twist: this phenomenon isn't unique to Venus. Any planet orbiting close to its star, especially those in the habitable zones of red dwarfs, where stellar activity is fierce, could suffer the same fate. That means exoplanets we've labeled potentially habitable might be hiding a dark secret. Their atmospheres could be bleeding into space, their oceans stolen by an electric wind they never saw coming. This raises a haunting question for astrobiologists. How many Earth-like worlds have we missed because their water vanished this way? And could life ever gain a foothold on planets where the atmosphere is being slowly erased? Some researchers speculate that microbial life might persist in the subsurface, sheltered from the ravages above. Others suggest that magnetic fields, even weak ones, could be the difference between a thriving ocean world and a desiccated husk. Venus stands as a cautionary tale, a reminder that habitability isn't just about temperature and water. It's about the invisible forces, the delicate balances that make a world truly livable. Yet there's hope in the chaos. By studying Venus's electric wind, we're learning how to spot its fingerprints on distant exoplanets. Subtle clues in starlight, missing hydrogen signatures, unusual ion trails, could reveal which worlds are losing their atmospheres and which might still cling to their life-giving oceans. Venus, once a twin to Earth, now serves as a cosmic lab, teaching us that the search for life isn't just about finding water. It's about understanding the storms we can't see, the winds that whisper through the void, and the fragile line between a living world and a ghost. Haumea isn't just another dwarf planet lurking in the Kuiper belt, it's a cosmic egg tumbling through space, spinning so fast it's been stretched into a bizarre, elongated shape. But that's not even the strangest part. This oddly deformed world is encircled by rings, a feature astronomers never expected to find around such a small, fast-spinning object. Imagine a pancake-shaped planet whirling end over end like a football, with 2 thin, dark rings orbiting its waist. This isn't Saturn with its iconic, icy loops. Haumea's rings are made of rock and ice, clinging to space just 1,000 miles above its surface, defying gravity with their delicate balance. How could rings possibly form around something so chaotic? Normally, rings need stability. Think of Saturn's tranquil, orderly system, where moons shepherd particles into neat bands. But Haumea completes a full rotation every 4 hours, flinging material outward with centrifugal force. The leading theory is pure cosmic violence, a colossal collision billions of years ago when another Kuiper belt object smashed into Haumea, shattering into debris. Some of that debris might have coalesced into Haumea's two known moons, Hioka and Namaka, while the rest got trapped in orbit, ground into dust and pebbles by subsequent impacts. But here's the twist: Haumea's rapid spin should have scattered that debris long ago. The fact that the rings persist suggests they're being continually replenished, possibly by micrometeorites chipping away at the dwarf planet's surface, or even by unseen moonlets lurking in the chaos. Then there's the mystery of their perfect alignment. Rings usually form along a planet's equatorial plane where gravity is balanced, but Haumea's extreme shape means its gravity is lumpy and uneven, yet the rings orbit neatly around its widest point. Some scientists think this could be a clue that Haumea's interior is denser than we thought, with a rocky core pulling debris into place despite the wild rotation. Others speculate that the rings are temporary, a fleeting snapshot of a system still settling after that ancient crash. What makes Haumea's rings truly groundbreaking is what they tell us about the solar system's diversity. Until their discovery in 2017, rings were thought to be the domain of giants Saturn, Jupiter, Uranus. Finding them around a tiny, misshapen world proves that nature's creativity has no limits. If Haumea can host rings, what else might be hiding in the Kuiper belt? Could other dwarf planets like Makemake or Eris have their own faint, undiscovered halos? The answer might rewrite our understanding of how ring systems evolve, and not just in our solar system. Exoplanets with wild orbits or irregular shapes could harbor similar surprises, challenging our search for habitable worlds. Haumea, with its egg-like wobble and ghostly rings, is more than a curiosity, it's a cosmic dare, pushing us to question every assumption about where beauty and complexity can thrive. Mercury's surface hides a glittering secret, vast plains of glass, stretching across the landscape like a cosmic stained glass window forged in fire. These aren't delicate shards or tiny fragments. They're massive sheets of smooth, solidified melt, some spanning miles, created when meteorites slammed into the planet with such force that they instantly vaporized rock and transformed it into molten rivers. As the liquid rock cooled in Mercury's airless void, it froze into sleek, glassy patches, capturing the violence of impact in their flawless, reflective surfaces. What makes these glass fields so extraordinary isn't just their scale, it's how they differ from anything on Earth. When volcanoes here produce glass like obsidian, it's typically dark and riddled with bubbles. But Mercury's impact glass is eerily pure, often clear or lightly tinted, with fewer imperfections thanks to the planet's lack of atmosphere. Without wind or water to erode them, these plains have stayed pristine for billions of years, gleaming under the sun's harsh light like alien mosaics. The Moon has its own versions, like the dark, glassy beads scattered across its surface by ancient lava fountains. But Mercury's glass is different. Its proximity to the Sun means impacts here pack extra punch, with temperatures so extreme they can melt not just surface rock, but also minerals deep below, creating larger, more varied glass deposits. Some regions, like the northern volcanic plains, are practically paved with the stuff, their smooth expanses interrupted only by the occasional fresh crater. Scientists are obsessed with these glass fields for more than their beauty. They're time capsules preserving clues about Mercury's volcanic past and the bombardment it endured during the solar system's chaotic youth. By studying their composition, researchers can trace the types of meteorites that once pummeled the inner planets, and even gauge how frequently these cataclysmic strikes occurred. Some glass deposits contain tiny bubbles of trapped gas, whispers of Mercury's ancient, long-lost exosphere, sealed away like cosmic amber. Then there's the tantalizing possibility that these gleaming plains could one day serve as resources for future explorers. Glass is a fantastic insulator, and its transparency could make it useful for shielding habitats or even crafting solar panels on site. But the real value lies in what it reveals. Mercury's glass isn't just a geological quirk. It's a mirror reflecting the brutal forces that shape the solar system, and a reminder that even the most scorched, airless worlds hold treasures waiting to be read like pages in a fiery, ancient book. Comet McNaught didn't just streak across the sky in 2007. It shattered expectations with a tail so bizarre it looked like it had been crimped by invisible cosmic hands. This wasn't your typical comet's flowing veil of dust and gas. As it swung around the sun, McNaught's tail developed a dramatic kink, a sudden pinch that made it resemble a celestial ribbon caught in a solar gale. The effect was so striking that backyard astronomers and professional observatories alike scrambled to document it, capturing one of the most visually stunning and scientifically puzzling comet displays in modern history. What caused this otherworldly deformity? The culprit was the sun itself, or more precisely, the solar wind, a relentless stream of charged particles blasting outward from our star at nearly 1,000,000 miles per hour. Normally, a comet's tail points away from the sun, pushed by the gentle pressure of sunlight and the solar wind's steady flow, but McNaught's tail got caught in a crossfire. As the comet neared the sun, it passed through a region where the solar wind's magnetic field lines twisted and reconfigured, creating a turbulent boundary known as the heliospheric current sheet. Think of it like a cosmic storm front where solar particles change direction abruptly. When McNaught's ion tail, made of charged gas molecules, crossed this boundary, the shifting magnetic forces yanked the tail sideways, warping it into that dramatic kink. The sheer visibility of this phenomenon was unprecedented. McNaught became the brightest comet in over 40 years, visible even in broad daylight for some observers. Its dust tail stretched across the sky like a searchlight beam, while the ion tail shimmered with an eerie blue hue, the result of carbon monoxide ions fluorescing in sunlight. But it was that twisted, pinched tail that stole the show, offering researchers a rare chance to see the solar wind's invisible forces written across the cosmos in real time. Beyond the spectacle, McNaught's tail held critical clues about the sun's behavior. By tracking how the tail distorted, scientists could map the solar wind's turbulent structure with unprecedented detail, something normally impossible to observe directly. The kink revealed hidden currents and magnetic eddies in the solar wind, like a probe revealing the contours of an invisible river. Some researchers even compared it to a giant cosmic MRI, with the comet's tail acting as a tracer die in the sun's magnetic bloodstream. The legacy of Comet McNaught lingers not just in textbooks, but in how we study space weather today. Its twisted tail proved that comets aren't just passive wanderers, they're dynamic tools reacting to forces we can't see and illuminating the hidden machinery of our solar system. And for those lucky enough to witness it, the sight was a humbling reminder. Even in the vastness of space, the smallest details can tell the grandest stories. Mars's moon, Phobos, wears its scars like a cosmic roadmap, grooves crisscrossing its surface in eerie, parallel lines, some stretching for miles across the tiny, misshapen world. These aren't random cracks, they're too uniform, too deliberate looking, as if someone dragged a giant claw across the moon's face. But the real mystery isn't their appearance, it's their origin. Are these grooves the agonized tremors of a moon being slowly ripped apart, or the aftermath of ancient cataclysms that shook Mars itself? The leading theory is as dramatic as it sounds. Tidal forces are tearing Phobos apart. Unlike Earth's moon, which drifts farther away each year, Phobos is spiraling toward Mars, inching closer by about 6 feet every century. As it falls, Mars's gravity pulls harder on the near side than the far side, stretching the moon like taffy. This relentless tug might be fracturing Phobos from within, creating those signature grooves as the crust buckles under stress. Some models suggest the grooves align perfectly with the predicted stress points of this slow-motion demolition, like fault lines on a doomed world. If true, Phobos could one day shatter entirely, scattering into a ring of debris around Mars, a fate Saturn's moons may have suffered eons ago. but there's a competing idea, one that ties Phobos's scars to Mars's violent past. When massive asteroids slam into Mars, they blast debris into space at blistering speeds. Some of that debris could have rained back down on Phobos, skidding across its surface like cosmic shrapnel, carving those grooves as it went. Evidence: some grooves radiate outward from Stickney crater, Phobos's largest impact scar, as if the crater's own ejector scarred the Moon on its way out. Even stranger, a few grooves seem to overlap later impact craters, suggesting they're younger than the surface around them, more like fresh wounds than ancient stress fractures. The debate gets weirder when you consider Phobos's composition. This moon isn't a solid rock, it's a rubble pile, a loose collection of boulders and dust barely held together by gravity. If grooves were stress fractures, you'd expect them to follow predictable patterns like cracks in drying mud, yet some zigzag unpredictably, defying tidal models. Could a rubble pile even have stress fractures, or would it just crumble like a crumbling cookie? On the other hand, if the grooves are ejector trails, why don't they curve as Phobos's orbit shifts over time? Clues might lie in future missions. Japan's Martian Moons E-Exploration MMX mission, launching in 2026, aims to land on Phobos, scoop up samples, and settle the debate once and for all. If the grooves contain Martian dust, it'd point to an impact origin. If they're lined with minerals formed under stress, tidal forces take the lead. Either way, Phobos isn't just a pockmarked rock. It's a living record of cosmic violence, a testament to how even the smallest worlds can bear the marks of giants. What's haunting is the timescale. If Phobos is being torn apart, we're witnessing the opening act of a breakup that'll climax in 30 to 50 million years. In cosmic terms, that's tomorrow. Future Martians might look up to see their moon unraveling, its fragments spreading into a glittering ring, a spectacle as beautiful as it is brutal. Until then, Phobos keeps its secrets locked in those cryptic grooves, a puzzle written in gravel and gravity, waiting to be decoded. Jupiter doesn't just dominate its moons with gravity, it wears one of them like a fiery halo. Meet Eo's plasma torus, a colossal donut of supercharged gas encircling Jupiter, fed by the moon's relentless volcanic fury. This isn't just a static ring, it's a churning storm of ionized sulfur and oxygen, a byproduct of Eo's volcanic plumes spewing material into space at a staggering ton per second. As these particles escape Eo's weak gravity, Jupiter's magnetic field snatches them up, accelerating them to breakneck speeds until they glow with an eerie electric blue, a cosmic neon sign writ large across the Jovian system. What makes this torus so extraordinary isn't just its scale. It stretches over 200,000 miles wide, but its role as Jupiter's ultimate power grid. The plasma doesn't just hover idly, it funnels along magnetic field lines like currents in a celestial circuit, dumping energy into Jupiter's poles and igniting auroras so intense they'd outshine Earth's northern lights 1,000 times over. Unlike our auroras driven by solar wind, Jupiter's are fueled from within, with Eo's torus acting as the battery. Every second, megatons of charged particles spiral down Jupiter's magnetic highways, striking the upper atmosphere with enough force to make the gas giant's poles shimmer in X-rays. But there's a darker side to this brilliance. The same plasma that paints Jupiter's skies also cooks its surroundings with deadly radiation. The torus is the heart of Jupiter's radiation belts, a zone so hostile it could fry spacecraft electronics in hours. Particles trapped here whip around at near light speed, creating a particle accelerator of cosmic proportions. This isn't just background noise, it's a defining feature of the Jovian system, shaping where moons can safely orbit and how future missions must navigate. Europa and Ganymede huddle outside the worst of it, while poor Io sits squarely in the crossfire, its surface bombarded with enough radiation to kill an unshielded astronaut in minutes. Yet the torus isn't just destructive, it's dynamic. solar activity tweaks its density, and Io's volcanic tantrums send shockwaves through it like boulders dropped into a river. When Io's volcanoes erupt, the torus brightens, its particles growing more energetic, a direct link between planetary geology and space weather. Scientists have even spotted blobs of plasma detaching like bubbles from a boiling pot, hurling mass and energy down Jupiter's magnetic field in chaotic bursts. The implications stretch far beyond Jupiter. Plasma tori might surround exoplanets with volcanic moons, their invisible glow hinting at hidden geologic activity. And if a moon like Io can power something this vast, what other unseen connections bind planets to their satellites? The torus is more than a spectacle. It's a lesson in celestial symbiosis, where fire and magnetism weave a bond that lights up the cosmos. Jupiter's auroras may blaze in the darkness, but their true story begins with a tiny, sulfur-stained moon and the electrified halo it can't escape. Beyond the scattered debris of the Kuiper belt, far past Neptune's gravitational grasp, lies a realm so distant it defies comprehension, the Oort cloud. This vast, hypothetical shell of icy fragments stretches nearly a light year from the Sun, a ghostly halo of comets and primordial rubble left over from the solar system's birth. But what if this frozen frontier isn't as empty as it seems? Lurking in the shadows, some scientists believe, could be a cosmic interloper of staggering proportions, Planet 9, a hidden giant whose gravitational whispers might be warping the orbits of distant objects in ways we're only beginning to decode. The clues are written in the strange, clustered paths of far-flung Kuiper belt objects. Take Sedna, for example, a dwarf planet with an orbit so elongated it loops out 12 times farther than Pluto, then dives back in without ever crossing paths with Neptune. Or the 6 smaller objects discovered in 2016, all tilted at similar angles and tracing bizarre, synchronized arcs that defy random chance. These orbits shouldn't align so neatly unless something massive, something unseen, were herding them like a celestial sheepdog. Enter Planet 9, a proposed world up to 10 times Earth's mass, lurking 20 times farther out than Neptune, its presence inferred solely by the gravitational ripples it leaves behind. But here's the twist: Planet 9 might not be alone. The Oort cloud could harbor other surprises. Rogue planets ejected during the solar system's chaotic infancy, now drifting in perpetual exile, or even primordial black holes, remnants of the Big Bang so dense they bend space itself. Some theorists speculate these dark travelers could explain anomalies in gravitational lensing data, tiny, unexplained flickers in starlight that hint at invisible mass passing between us and distant stars. The hunt for Planet 9 is already reshaping our tools. Telescopes like the Vera C. Rubin Observatory, set to scan the skies in the mid-2020s, could spot its faint infrared glow against the cosmic backdrop. Others are searching for thermal signatures, the faint heat of a world too distant to reflect sunlight. But the real challenge isn't just finding it, it's explaining how it got there. Did it form closer to the Sun and get flung outward by a gravitational slingshot? Or was it captured from another star, a cosmic orphan adopted by our solar system? What's electrifying is the possibility that Planet 9, if it exists, could rewrite our cosmic family tree. Its gravitational influence might explain why the solar system's plane is slightly tilted, or why some comets from the Oort cloud veer inward at odd angles. And if it's not alone, if the Oort cloud shelters other massive objects, we may be on the brink of discovering an entire hidden layer of our own solar system, a secret history written in ice and shadow. Until then, the Oort cloud remains the ultimate cosmic cold case, its mysteries preserved in the deep freeze of space. Every odd orbit, every anomalous flicker of light, is a breadcrumb leading us toward truths we haven't yet imagined. Whether Planet 9 is out there or not, one thing's certain: the edges of our solar system are far stranger, far more alive with possibility than we ever dared to dream. From Saturn's geometric hexagon to Pluto's tumbling moons, from Mercury's glass plains to Venus's ocean-stealing electric wind, we've journeyed through 25 of the solar system's most jaw-dropping enigmas, each one rewriting the rules of what we thought possible. These aren't just curiosities, they're cosmic game-changers. Europa's hidden ocean and Enceladus's salty plumes force us to ask, is life lurking in the shadows of our own backyard? Haumea's rings and Arakoth's snowman shape reveal how chaos and chance sculpt worlds in ways textbooks never predicted. And let's not forget the lingering whispers of Planet 9, a phantom giant that could still be hiding in the frozen dark, tugging at the edges of everything we know. Every discovery peels back another layer of our solar system's strangeness, proving that the universe thrives on surprises. Think about it. We once saw planets as neat, orderly spheres following perfect orbits. Now we know they're dynamic, messy, and downright rebellious, sporting storms that outlast civilizations, moons that spew volcanoes into space, and atmospheres that vanish into the void. Even the asteroids and dwarf planets, once dismissed as boring space rocks, turned out to be time capsules holding the raw ingredients of planetary birth. But here's the wildest part: we're only scratching the surface. For every mystery solved, a dozen more emerge. What's churning beneath Titan's methane lakes? Is Psyche really the heart of a murdered planet? Could Martian methane be the breath of some stubborn microbe? The more we learn, the clearer it becomes. The solar system isn't some static museum exhibit. It's a living, breathing, ever-changing puzzle, and we've got front-row seats to the greatest show in the galaxy. So, what's your favorite cosmic head-scratcher? Drop it in the comments. We're obsessed with these debates, and if you're hungry for more mind-bending space stories, hit that subscribe button. The universe is stranger than fiction, and together we're just getting started on unraveling its secrets. Keep looking up, because out there in the great unknown, the next big discovery is already waiting.